Hello friends, in our previous lecture we have completed 4th chapter of accountancy, that is journal entries. Please refer that chapter again and again because all the chapters are based on that. Okay, now we are moving forward to the next chapter, and this is most probably the last chapter for the first term exam, that is chapter number 4 in statistics, measures of dispersal. If government is saying nothing, then this would be the last chapter for the first term examination. Now these methods of dispersion, we are learning so much of new measures, but some of them are excluded from the course. Now first let us to be known that what is these actually measures of dispersion. Dispersion means scattering. The word dispersion you have heard in science also, that whenever we are taking a prism and the colors we are refracting with the torch, it is dispersing, means how it is scattering or how it is spreading, that we are learning in science. Same thing is learned here also when we are taking any two measures, then or any one measure, then how it is spreaded over the area. So to learn about that, we are having 4 measures of dispersion here, that is range, quartile deviation, mean deviation, standard deviation. Totally there are 6 exercises, but half of the exercises has been cut out from the syllabus due to this corona. Okay, now first let us discuss that thing only, that which things are in our course and which things are not in our course. So first of all, everyone will write in your notebook clearly the same. Okay, so everyone first write the name of chapter number 4, measures of dispersion. In that topics to be included topics to be excluded. In previous chapter I was telling directly, now here topics are included and some of the topics are excluded, so we can show it as. Okay, so the first topic of the chapter is about range, the first measure of dispersion, that is excluded from the chapter. So range, exercise 4.1 is totally excluded, we don't have to do it. Second topic of the chapter is quartile deviation. That is exercise 4.2. So this is to be done. Then the third topic, mean deviation, that is exercise 4.3, that is also deducted. Then fourth measure is standard deviation, that is exercise 4.4, that is included. Then next coefficient of variation, that is learning exercise 4.5, that is there in the course, but again combined standard deviation, that is exercise 4.6 is excluded from syllabus. So you have to write this thing, my friends. We will learn only these topics, that is exercise 4.2, 4.4 and 4.5 we will learn, but we will not learn 4.1, 4.3, 4.6 as per this latest guidelines of government. If again they are telling, then I will start these things, I don't have any problem. Okay, so 4.1, 4.3 and 4.6 are to be deducted, 4.2, 4.4 and 4.5 are to be kept in the syllabus. Now if we are telling about the measures of dispersion, there are four measures: range, quartile deviation, mean deviation and standard deviation. Now we are not learning these measures. This you have already learned in previous chapter only, in second chapter, that maximum value minus minimum value. If this is there and also not there, nothing is problem. Mean deviation is same like standard deviation also. A slight change is there, so that is also not required. But these are all the topics which are very important, and it is useful in standard 12th also. This thing is also not useful. These things which we have kept are useful in standard 12th perfectly. Okay, now let's go for the chapter. What the chapter is telling. So much things are explained that is not required. Now first you underline on page number 123 a definition of dispersion is given rightly here on page number 123. Underline this definition. A measure which shows how far the observations of the data are scattered from the measure of average is called dispersion. So you should know that thing. After that, come to page number 124. We are discussing one or two things about this chapter, and then we are starting this topic. Okay. So on page number 124, desirable characteristics of measures of dispersion. How should be the characteristics for measures of dispersion? This is for our general knowledge. This will not come in exam, but this is for just a discussion about the sums. Number one, the definition of measures of dispersion should be clear and unambiguous. Means the measures which we are learning, whether it is to be learned or not to be learned, the measures should be such that it is understood by all. It should be clear and unambiguous, means it should not be very difficult to understand. It should be simple and easy to compute. The calculation which we are doing should be very easy to compute, not it should be complicated, otherwise all cannot calculate. It should be based on all the observations. The things which we are calculating are to be based on all the observations of the data, not to exclude any observation. It should be suitable for future algebraic and statistical calculations. If further also you need to derive some calculation, then that measure of dispersion should be possible. It should be a stable measure in the sense that if different samples of equal size are drawn, measures of dispersion are obtained, the value of this measure should be almost the same for all the samples. Means if you are changing the samples, then overall your value must not change so much far. If it will change by somewhat change, but it should not change for long. It should not be unduly affected by very large or very small observation. By mistake, if we have added any observation, or by mistake we have taken any observation, and if we are replacing that, then the answer should not change so much far. This is only for our general knowledge. Now, concept of absolute and relative measures of dispersion. In each measure of dispersion, we are having two formulas, that is absolute and relative. Now let's see what is this absolute and what is this relative. A measure of dispersion which is expressed in same statistical units in which the observations of the data are expressed is called an absolute measure of dispersion. For example, if the original data are in kilogram, an absolute measure will also be in kilogram. So the original measure which we are showing, that is called an absolute measure. An absolute measure is not useful for comparison purpose of variability of two or more sets of data having different units of measurement. Okay, it is not useful for comparison. Some are in kg, some are in kilo, some are in grams, some are in milligrams, then some are in meter, liter. Then that thing is not easy to compare. Then relative measure. A measure of dispersion which is free from unit of measurement is called relative measure. The variability of two or more sets having different units can be compared by a relative measure. Generally, a measure of relative dispersion is the relative measure of an absolute dispersion of observation of set of appropriate average of observations. The relative measure of dispersion is known as coefficient of dispersion as it is independent of units. They are telling that absolute measure is based on the thing which is given in the question itself. So the unit, if we are using kilogram, then in whole question the answer will be with kilogram. And relative measure is the measure as overall. We are showing it in a ratio form. So it is free from units. So it is easy to compare with some other units, that is liter or meter or anything. That thing we will learn in the formula when it is coming. Okay, so this is the introduction of the chapter. Now we are excluding range and directly we are starting quartile deviation. So range topic is excluded. So 4.1 is excluded. Now come to page number 128. We are going for quartile deviation. Okay. Now what is this quartile deviation? We know that only extreme observations, that is largest and smallest observations, are used in computation of range. Similarly, by positional measures known as first quartile and third quartile, another measure of dispersion, namely quartile deviation, is obtained. So quartile deviation uses only first and third quartiles, that is extreme, not between quartile, that is second quartile. The measure of variation defined by using the middle 50% observation arranged in increasing order of magnitude is called quartile deviation. The measure of quartile deviation is obtained by difference between Q1 and Q2 divided by 2. Symbolically it is denoted by QD. We can write the formula as follows. QD means quartile deviation is equals to third quartile minus first quartile divided by 2, and this quartile deviation is also known as, the other name of quartile deviation is semi-interquartile range. If QD is divided by the mean of Q1 and Q3, we get the relative measure. Now the formula is Q3 minus Q1 divided by Q3 plus Q1. This explanation is not required. The relative quartile deviation is also known as coefficient of quartile deviation, and note that QD, unit of measurement in which the observations are expressed, but the coefficient of quartile deviation is independent of such. So in quartile deviation and in every absolute measure we will write the units, and in coefficient we will not write the units. Now let's write the formula. So everyone give the heading quartile deviation. So everyone give the heading in your notebooks. Quartile deviation. We will write based on middle 50% observations, based on extreme quartiles, that is Q1 and Q3. Now we are writing formulas. Okay. Quartile deviation QD is equals to Q3 minus Q1 divided by 2. This is absolute measure. This is absolute measure, and with units. Means the unit given in question is used. Coefficient of quartile deviation. It is not denoted by anything. Directly if we write the formula, Q3 minus Q1 divided by Q3 plus Q1. This is a relative measure. Okay. The other name of quartile deviation is semi-interquartile range. Other name of coefficient of quartile deviation is relative quartile deviation. These are the other names. So quartile deviation is based on middle 50% observations, is based on extreme quartiles. Extreme quartiles means Q1 and Q3. Formula for quartile division is Q3 minus Q1 divided by 2. This is absolute measure. This is with units. And the other name is semi-interquartile range. Coefficient of quartile deviation. The other name is relative quartile deviation. Formula Q3 minus Q1. Same thing. Don't divide by 2. Divide by Q3 plus Q1. This is relative measure, and this is free from unit. Now let's solve exercise 4.2. On page number 133, perfect 3 sums are given. One is of ungrouped, next is of discrete, and next is of continuous data. Okay, so one each is given. So on page number 133, we are having exercise 4.2. A shooter missed his target in last 10 trials by following distance in millimeter during practice session 20, 32, 24, 41, 18, 27, 15, 36, 35, 25. Find quartile deviation and coefficient of quartile deviation of such distance missed by shooter. So we are going for exercise 4.2. We are having first sum. Targets missed by shooter 20, 32, 24, 41, 18, 27, 15, 36, 35, 25. Now friends, this is ungrouped data, and you should remember that for ungrouped data, whenever we are calculating median and its positional average, it is to be rearranged in ascending order, and the formula for quartiles also not required to write because we have written in previous chapter itself. So first we need to arrange. If you are not arranging, then your answer will be wrong. Arranging the data into ascending order. Okay. The smallest value is 15, next 18, next 20, then 24, 25, 27, then 32, 35, 36, 41. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. N is equals to 10 trials. Okay. Now, for calculating quartile deviation, directly we cannot calculate quartile deviation. For that we need 3 quartiles. So first we will, not 3 quartiles, 2 quartiles, first and third. So first we will calculate that thing. Okay. So if you are thinking that sums are very small, it is not small. Calculation of quartiles. These sums are very big. Okay. First of all, we will write a common formula Qj. J is equals to 1, 2, 3. Now, as this is ungrouped data, Qj is equals to value of J n plus 1 by 4th observation. Now we need Q1. First we are calculating Q1. So Q1 is equals to value of 1 in bracket 10 plus 1 by 4th observation. Value of 1 in bracket 10 plus 1 11 by 4th observation. Value of I think 2.25. 11 divided by 4 multiply 1 is 2.7. So value of 2.75th observation. Now as you know, this is ungrouped data, and whenever we are having decimals, see the rules are from previous chapter. If you are understanding the previous chapter, then only it is possible. So whenever these things comes, so take that observation with integers. So second observation plus 0.75 after decimal, then the next observation is third observation minus the current observation, second observation. So this is the method. If you are not aware of previous chapter, then nothing will happen. So value of second observation plus 0.75 in bracket third observation minus second observation. So value of second observation is 18 plus 0.75. Value of third observation is 20. Value of second observation is 18. So 18 plus 0.75 multiplied to 18 plus 0.75 into 2 is 1.5. So the answer is 19.5 millimeters. It is Q1. For that you have to know the little concepts. Okay. Now the second calculation is about Q3 is equals to value of 3 in bracket 10 plus 1 divided by 4th observation. Value of 3 in bracket 11 by 4th observation. Value of 11 by 4 into 3, 8.25th observation. So how you will write? Value of that current means 8th observation plus decimal 0.25 in bracket, next is 9th observation minus current 8th observation. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 8 is 35 plus 0.25 in bracket. Next, 9th observation is 36 and current observation is 35. So 35 plus 0.25 multiply 1. 35 plus 0.25. It is 35.25 millimeters. Q3. So we obtain Q3 also. Now we have to obtain quartile deviation. So number 3. Quartile deviation. QD is equals to, what is the formula? Q3 minus Q1 divided by 2. 35.25 minus 19.5 divided by 2. 35.25 minus 19.5. 15.75 upon 2. 7.875 means 7.88 mm. It is 7.875, so I am rounding off 7.88 millimeters. Next we need also coefficient of quartile deviation. So I am calculating here. So number 4, coefficient of quartile deviation. So it is Q3 minus Q1 divided by Q3 plus Q1. So 35.25 minus 19.5 divided by 35.25 plus 19.5. Numerator we have 15.75. Denominator 35.25 plus 19.5. 54.75. Now 15.75 divided by 54.75, it's 0.287, so 0.29. So this is the method to solve the sum, my friends. First sum of quartile deviation was about ungrouped data. So don't think that this much only calculation is there. For calculating this thing you need third and first quartile. So first we have calculated first quartile, then the third quartile, then quartile deviation and then coefficient. But friends, for that you require the revision of third chapter or you require the formulas of third chapter. If you are unaware of the third chapter, previously only I have said all these things are used in next chapters. So if you are aware totally with the formula, then it's not a problem. But if you are unaware, then it's a big problem. So this sum was with the ungrouped data. Now let's solve with the discrete data. Second sum. second side. Find quartile deviation and coefficient of quartile deviation of marks from the following frequency distribution of marks of 43 students of a school. So marks, that is x, number of students, that is frequency. We need CF because we need to decide the observation. We need CF for that. So marks is column X, number of students is column F, and we need CF. 10, 20, 30, 40, 50, 60. 4, 7, 15, 8, 7, 2. Sigma F is equals to N is equals to 4, 7, 15, 8, 7, 2, 43. Now CF. 4 is 4, 7 plus 4, 11, 11 plus 15, 26, 26 plus 8, 34, 34 plus 7, 41, and 41 plus 2, 43. This should match. So let's calculate all the quartiles, and then we will calculate, sorry, not all the quartiles, every time I am mistaken. Let's calculate first and third quartiles, and then we shall go for quartile division and coefficient of it. Okay. Now calculation of quartiles. We will write the formula on the ones. Cube J. J is equals to 1, 2, 3. Is equals to value of j in bracket n plus 1 divided by 4th observation. Now number 1 we need given value of 1 in bracket 43 plus 1 divided by 4th observation. Value of 1 in bracket 44 divided by 4th observation. Value of 44 by 4, 11, 11 ones are 11th observation, C in CF. 11th observation is executed. So 11th observation lies in CF 11 only, with value of x is equals to 20. Therefore Q1 is equals to 20 marks. This is little bit easy because if we are having continuous data, then still we have decided class of, then we have calculation, but here directly. So 44 by 4 means 11 ones are 11th. 11th observation's value is 20. Is like 11th observation lies in CF 11 only, with x value 20. So Q1 is found. Now Q3. Second calculation, Q3 is equals to value of 3 in bracket 43 plus 1 by 4th observation. Value of 3 in bracket 44 by 4th observation. Value of 44 by 4 is 11. 11 threes are 33rd observation. This 33rd observation we will see in CF. So 33rd observation will be in CF 34. 33rd observation lies in CF 34 with value of x is equals to 40. Therefore Q3 is equals to 40 marks. Easy thing. Next, quartile deviation. See, this quartile deviation is not difficult. Difficult thing is to calculate first and third quartile, because the calculation is little bit lengthy. QD is equals to Q3 minus Q1 divided by 2. 40 minus 20 divided by 2. 20 divided by 2. 10 marks. Quartile deviation. And next, number 4. Coefficient of quartile deviation. Q3 minus Q1 divided by Q3 plus Q1. 40 minus 20 divided by 40 plus 20. 20 by 60. 0.33. So friends, we have completed the sum using discrete data also. The thing was to calculate the quartiles with discrete data. So friends, if I am saying in short that this chapter is just the revision of previous chapter for first part, that we are repeating these quartiles, then only new measures are found. So you should know that chapter. And now we will solve the next sum, which is for continuous data. So first we solved about ungrouped, then about discrete. Now finally the continuous. Little bit sum will be lengthy because calculating quartile will take some time. Okay. Last sum. The distribution of amount paid by 200 customers coming for snacks at a restaurant on a particular day is given below. Find the quartile deviation and coefficient of quartile deviations for the amount paid by customers on that day. So class and frequency column is given, we need only cumulative frequency. So this is third one. Amount in rupees, this is class column. Number of customers, it is frequency. We need cumulative frequency. 0 to 50, 50 to 100, 100 to 150, 150 to 200, 200 to 250. Frequency 25, 40, 80, 30, 20. Sigma F is equals to N is equals to 25, 40, 80, 30, 25, 128. So 25, 25 plus 40, 65 plus 80, 145 plus 30, 175. Oh yeah, I made a mistake. 25, 40, 80, 30 and 25. Sorry, here I have made a mistake. 2. Now let's start the calculation. I am starting from here itself, not here, because calculating quartiles will be a little bit lengthy. Calculation of quartiles. Number 1, Q1. Because here it requires the steps personally. In that first step, decide quartile class. Qj, j is equals to 1, 2, 3 is equals to class containing j n by 4th observation. We need Q1, class containing 1 in bracket 200 by 4th observation. Class containing 200 by 4 is 50. Ones are 50. 50th observation. So this 50th observation will lie in class 50 to 100. 50th observation is in CF. Here I am writing C in CF. Is in CF 65 with class 50 to 100. The classes are exclusive, that is a good thing. Second step, find out quartile. Qj, J is 1, 2, 3 is equals to L plus Jn by 4 minus Cf upon F multiply C. We need Q1, lower boundary point L is 50 plus Jn by 4 from the previous step 50. Cumulative frequency of previous class is 25. Frequency of the class decided is 40 and the class length is also 50 because 150 difference is 50. Okay, 50 plus 25 by 40 multiply 50. 50 plus 25 into 50 upon 40, 31.25. So the answer is 81.25 rupees. For class, we have the unit as rupees. So this is the first quartile. Let's find next quartile, that is third quartile. Second one, Q3. First step, decide quartile class. For that, Qj, J is 1, 2, 3 is equals to class containing J n by 4th observation. We need Q3. Q3 is equals to class containing 3 in bracket 200 by 4th observation. So class containing 20 by 200 by 4 is 50. 50 into 3, 150th observation. Now this 150th observation is in 150 to 200. 150th observation, C CF, lies in CF 175 with class 150 to 200. Okay. So second step, find out quartile. Formula Qj, J is 1, 2, 3 L plus J n by 4 minus Cf upon F multiply C. We need Q3. L is 150, lower boundary point, plus Jn by 4 is also 150. Cumulative frequency of previous class is 145. Frequency of class decided is 30 and the class length is again 50. 150 plus 5 divided by 30 multiply 50. 150 plus 5 into 50 by 30. 8.333, so 8.33, so answer is 158.33 rupees. So friends, Q1, Q3 are over. Now we shall go for quartile relation and coefficient of elimination. So the sum is still continued. These are two answers. I am not rubbing. Third step, quartile deviation. QD, Q3 minus Q1 upon 2. 158.33 minus 81.25 divided by 2. 158.33 minus 81.25, 77.08 upon 2, 38.54 marks. Last step, coefficient of quartile deviation is equals to Q3 minus Q1 divided by Q3 plus Q1. 158.33 minus 81.25 divided by 158.33 plus 81.25. This difference is here. 77.08 divided by 158.33 plus 81.25, 239.58. 77.08 divided by 239.58. Answer is 0.321, so 0.3. So friends, I think today we have completed this exercise very soon, and the reason is simple. If you know first and third quartiles formula and you know to find it, then you will do it very easy. And this speed is required in the exam also. If you think that your paper should be completed of accountancy and statistics, this speed is required. That formulas directly should stuck your mind. If it's not so, then you cannot complete the paper. So be in this speed. Plus think twice what to write. This is only commerce. This is just a starting. After that you will come in 12th and you will come in college. Double speed is required, and if you are not calculating in that speed, nothing. This is only commerce. Okay, so I hope that all are understanding the things. So write this thing and send it to me as soon as possible. That's all for today. We are going for the next topic tomorrow. Thank you.